Hey guys, this is section 11.3 and 4 about Bernoulli's law and Pascal's principle. So what Pascal's principle has to do, we're talking about fluids, is that when a force is applied to a confined fluid, the change in pressure is transmitted equally. So just think of the water bottle that's shown here. If you squeeze it in the middle, the water is going to go in all directions. That's why it usually doesn't go up very much. Now, if you open the top and you squeeze it, then because it's now not a confined fluid, it's going to find the way out. Think of it like squeezing a balloon as well. When you squeeze one part of the balloon, it just doesn't go in one direction. It exerts that fluid, the air, in all directions. This is used a lot in hydraulic devices. So hydraulic devices, think about hydro, right? Hydro usually means water. So hydraulic devices is something, usually it has water or some kind of fluid. And a force is applied to one piston and it pushes, because of Pascal's principle, through the fluid equally. And then it's able to transmit that force and allow this piston to push up. Because remember, pressure is force over area. So we can use hydraulic systems with a small piston here and a very, very large piston here to do more work for us. So if I apply force on a small piston, which doesn't take very much effort on my part, and it distributes all of that pressure equally, then this large piston is going to be able to lift something up or move something in an upward direction. And so it's increasing the force, the work that's being done. Hydraulics are used in your car in the brakes, because think about your brake. You have a pedal which is about the size of your foot, depending on the size of the car, and it pushes on a piston situation here, and it pushes on the brake pad, which stops this disc and the wheel from moving. Now, Bernoulli's principle, it says that if we speed up fluid, think of air. If the speed of moving air or fluid increases, then the pressure decreases. And that's what happens in a convertible on a roller coaster. The air is increasing up here as you're moving, so your hair goes up. Same thing when you're on a boat. And that's why if it's really windy, that's why your umbrella will pop. It explains how things fly as well, because if you notice a plane's wing, it's not completely flat, it's curved, much like a bird's wing. And what allows to happen is, because of the forward thrust of the engines, the air on top has to move faster to get to the back. And so they're faster than the air on the bottom. And so you've created an area up here of less pressure, which helps this thing lift off the ground. That's called lift. It can be applied to a perfume bottle. If you're squeezing, and these are those old-fashioned perfume bottles, or even kind of a pump aerosol bottle, you're creating an area of low pressure here, because you're speeding up the fluid right here at the very tip of this tube. And because there's pressure here inside the perfume bottle pushing down, and everything's balanced out before that, but when you squeeze this and speed up the fluid here, then this pressure pushes the perfume down and up the tube, and then it comes out because you created a low area of low pressure versus the area of higher pressure, which was in the bottle. And that's how your fireplace works. If you have a wood-burning fireplace, wind is up here, you're creating an area of low pressure, so the fire is here, and that higher pressure pushes the smoke out. If you don't have wind up on top, a lot of times what happens is that you'll get the smoke coming into the house. Frisbees are another good example of how you apply Bernoulli's principle, and it's shaped in this arc. Even those foam ones usually has a cutout at the bottom. Again, it's because it makes the air go faster over the top than on the bottom, so it creates that upward push, which is lift. And that's it.